Hello everyone. Our first module for fluid mechanics 2 is on flow through pipes. The topics that I will try to cover in this lecture is I will first introduce the topic, then we will see the loss of head through pipes, that is through Darcy-Weisbach equation. Then what are the losses, that are major losses and minor losses? What is meant by hydraulic gradient line and total energy line? Pipes in series, equivalent pipes, pipes in parallel, flow through branch pipes, siphon and three reserve problems. So what is pipe? A pipe is a passage with a closed perimeter through which the fluid flows under pressure. The fluid flowing in the pipe is always subjected to resistance due to shear forces between fluid particles and surface of the pipe. There is a resistance between fluid particles and the surface of the pipes when the fluid passes through the pipe. This resistance is called as frictional resistance, and due to this some of the energy of fluid is lost, that is called as energy loss. So head losses through pipes. What are the head losses through pipes? They depend mainly on the type of the flow. There are two types of the flow depending upon the Reynolds number. First is the laminar flow. This type of flow is the flow in which the flow of fluid travels smoothly and in a regular path. In this, Reynolds number is always less than 2000. We can classify this laminar flow based on the Reynolds number when Reynolds number is less than 2000. Then comes the turbulent flow. It is the type of flow of fluid in which fluid undergoes irregular fluctuations and mixings. In turbulent flow, Reynolds number is always greater than 4000. Okay, so we will move towards the types of losses. What are the types of losses? There are two types of losses, that are minor losses and major losses. Minor losses are the ones which are generated due to the eddy formation. In a pipe, due to sudden contraction or expansion of the pipe, the velocity changes and this gives rise to the eddy formations. So, the energy loss due to eddy formation comes under minor losses, and the major losses are the ones which are due to the friction between the fluid particles and the pipe wall. So further minor losses are categorized into 5 types, that is loss due to sudden enlargement, loss due to sudden contraction of the pipe, loss at the entrance, loss at the exit and loss due to the pipe fitting. We will see them one by one. So major loss. Loss of head due to friction is termed as major loss. It mainly depends on the velocity of flow, diameter of pipe and the roughness, and it is denoted by H small f, suffix f. So the equation for head loss due to friction is FLV square by 2GD. Here F is friction factor, and if we have provided coefficient of friction, then this equation becomes HF is equal to 4FLV square by 2GD. Then we will move towards the minor losses. This is due to the distribution in the flow pattern. The first loss, minor loss, is loss due to the sudden enlargement. This loss is due to the sudden enlargement of the pipe. It is denoted as He, and the equation to find out the loss due to sudden enlargement is V1 minus V2 raised to 2 divided by 2G. Okay. Then we will move toward the second type of minor loss, that is loss due to sudden contraction. When the diameter of the pipe gets suddenly reduced, then the loss which is occurred is called as the sudden loss. Then it is denoted by HC. It is given by 1 divided by Cc minus 1 whole bracket to the square into V square by 2G. The third type of minor loss is loss at the exit. It is the head loss at the exit of the pipe. It is denoted by H suffix EX. Also it may be denoted by H suffix I. Its equation is V square by 2G. Next loss is loss due to the pipe fittings. It is due to the pipe fittings like elbows and walls, etc. It is denoted by HP and the equation is capital K into V square by 2G. So last one is the loss at the entrance. It is the head loss at the entrance of the pipe and it is denoted by H suffix En. The equation is 0.5 bracket V square by 2G. So now the next topic is hydraulic gradient line and the total energy line. Hydraulic gradient line is a line which gives the sum of the pressure heads, that is P by rho G, and the datum head, that is Z, of a flowing fluid in a pipe with respect to some reference line. We can see this diagram. This is the datum, this is the pipe, and this is the center line. Now Z1 is the datum head and P1 by rho G is the pressure head. So hydraulic gradient is nothing but a line which gives the sum of the pressure heads P by rho G and the datum head Z. So P by rho G plus Z, this is nothing but hydraulic gradient line, and the line drawn through these points is called as hydraulic gradient line. Now we will move towards the total energy line. A line which gives the sum of the pressure heads P by rho G, datum head Z, and kinetic head V square by 2G of a flowing fluid in a pipe with respect to some reference line. With respect to some reference line, the summation of Z1 plus P1 by rho G plus V1 square by 2G gives the total energy line. This is the total energy line and this is called as hydraulic gradient line. Then we will move towards the pipes in series. Pipes with different lengths and different diameters are connected end to end, forming a pipeline. We can see in this figure, pipe 1 has a greater diameter as compared to that of the pipe 2, and pipe 2 has a lesser diameter as compared to pipe 3. So pipes with different lengths and different diameters connected to each other, forming a pipeline, is called as the pipes in series. The discharge flowing through all of the three pipes will be same. Q1 is equal to Q2 is equal to Q3. Therefore, total head loss will be H1 plus H2 plus H3. Okay. So, this is the equation used to calculate the total head loss when pipes are in series. H is equal to 4F divided by 2G whole bracket L1 V1 square by D1 L2 V2 square by D2 plus L3 V3 square by D3, summation of L1 V1 square by D1 plus L2 V2 square by D2 plus L3 V3 square by D3, where L1, L2 and L3 are the lengths of pipe 1, 2 and 3. V1 is the velocity passing through the pipe 1, V2 is the velocity passing through pipe 2 and V3 is the velocity passing through pipe 3, and D1, D2, D3 are the diameter for the respective pipes. Further, we will see what is equivalent pipe. A compound pipe consists of several pipes of varying diameters and length is to be replaced by a pipe of a uniform diameter known as the equivalent pipe. When number of pipes which consist of a varying diameter and length has to be replaced by a single pipe with a uniform diameter, it is called as equivalent pipe. The equation for the equivalent pipe is L by d raised to 5 is equal to L1 by d1 square plus L2 by d2 square plus L3 by d3 square, where L1 is the length of the equivalent pipe 1, L2 is the length of the equivalent pipe 2, and L3 is the length of the equivalent pipe 3. D1 is the diameter of the equivalent pipe 1, D2 is the diameter of pipe 2, and D3 is the diameter of pipe 3. Further, we will see pipes in parallel. When a main pipe is divided into two or more parallel pipes, which again join together downstream side and continue as a main line, the pipe are said to be parallel. See, this is the main pipe which is divided into three parallel pipes, and in the downstream they are joined together and continue as a main line. So in the type of arrangement, rate of flow in the main pipe, that is Q, is equal to sum of rate of flows through the branch pipes, that is Q is equal to Q1 plus Q2 plus Q3, and the loss of head for each pipe will be same. H1 H2 is equal to H3. So we will move towards the flow through branched pipes. So when two or more reservoirs are connected by means of pipes having one or more junctions, the system is said to be a branching pipe system. See, these reservoirs are connected to each other by means of pipes and are having one junction. So on this, a three reservoir problem is solved. Three reservoirs at different levels which is connected at a single junction. So three reservoir problem. The L, D and HF of each pipe are given. It is required to find out the discharge and direction of flow in each pipe. In three reservoir problem, we have given the parameters of pipes. Only we have to find the discharge and direction of flow in pipes. For this, the basic equations are used. Continuity equation, that is inflow of fluid at the junction is equal to outflow of the fluid. Second, we use Bernoulli's equation, and third, we use the Darcy-Weisbach equation. In next lecture, I will be showing how the problems are solved on three reservoir problems. So now we will move towards flow through siphon. When the two reservoirs are separated by a hill or a high level ground, a long bent pipe is used to transfer the liquid from a reservoir and a higher elevation to reservoir at a lower elevation. Okay, so these two reservoirs, this reservoir is at a higher elevation than this reservoir. So to carry out the water from this reservoir to this reservoir, a bent pipe is used, which is called as siphon, and these two reservoirs are separated by a hill. So what are the applications of siphon? Siphon is basically used in following cases. First, to transport the water from one reservoir to the another reservoir separated by a hill or a ridge. Second, to take out the liquid from a tank which is not having any outlet. And third, to empty a channel not provided with any outlet sluice. So let us consider that we have the two reservoirs, that is A and B, and are separated by a hill. So siphon is connected with reservoir A and reservoir B. Point C will be at the highest of the siphon, which will be termed as summit. The flow flowing through the siphon will be only possible if the pressure at point C is below than the atmospheric pressure. Okay, the water will flow through the siphon only if the pressure at C is less than the atmospheric pressure. The pressure at point C will be less than the atmospheric pressure because point C is above the free surface of the water. Point C is above the free surface of the water in the tank A. This is the water level in the tank A, and point C is located above the free surface of the water in the tank A. This difference in pressure will cause the flow of liquid through the siphon. This difference in pressure will cause the flow of liquid through the siphon. Theoretically, pressure at point C may be reduced to 10.3 meters of water, but in actual practice, this pressure will be minus 7.6 meters of water. Thank you.